In this situation, what we're doing is we're trying to make a decision between who talks more, women or men. And this kind of to help the scenario here a little bit, I was in a discussion with my wife the other day, and she said, "Well, I think men talk more than women," and I'm like, "Oh, I don't think so." So so in this situation, the purpose is you obviously want to figure out who's right and who's wrong, and as you know, that's I'm probably wrong. After 35 years of marriage, I figured out that it's probably best just to go with that right up front. Regardless, the research question is going to be who talks more? Very easy. Who talks more? Men or women? Okay. We start out with the null. They talk the same amount. Okay. The alternate is they do not. Do not talk the same amount. Men and women do not. All right. Means testing. Which technique would you use? As you can see here, we are not going to get the standard deviation for the population, so we're going to do a t-test, and we're going to do a two-tail because we're talking again about do they talk the same or not. That would indicate a two-tail. And if it said less than or equal to or greater than or equal to, something along that line, you do a two-tail. But I'm going to go with what the textbook suggests, which is basically that you start out with a null that's a two-tail. So we're going to do a two-tail t-test. We're going to run that at 95% confidence level, as always, or p less than 0.05, which means there's a 5% chance you're wrong, and there's a 95% chance you're right. The other way you'd see this written as a script 0.05. Now, this one's kind of involved. It's got a pretty serious formula. And by the way, I'm not going to do these calculations. I've already got them done here, so I'll go ahead and calculate them, and then you can verify the calculations on your own. But I've done a couple things here. One is I did change that from p.01 to p.05. And then the other thing I want to do is change it from the n sub 1 for men, the sample size for men, to 91. It doesn't substantively change the question, but it does allow for us to use the t-chart. So, calculate the test statistic. And I'm going to show you how to do that with this formula. The formula you would be used or given, and it'll be a much easier formula than this. Okay, and the formula you will be given is the following. It will be equal to x bar sub 1 minus x bar sub 2. So this is men, this is women, and then you're going to divide that by the square root of s sub 1 squared over n sub 1. Right here. S sub 1, n sub 1 is 91. We know what our x bar sub 1 is, so we're in pretty good shape. And you add s, the standard deviation sub 2, and this is, square that up, and this is for women. And so we're going to use the n sub 2, and n sub 2 in this situation is 210. Here's the x sub 2. Here's the n sub 2, standard deviation, on and on. Keep in mind that we did change that to 91. So now, if you put that into this, kind of did some plugging and chugging here, you would end up with a minus 0.52. You can go ahead and do those calculations on your own to verify it. If you find out that there's something different, do let me know. I'd be happy to redo my calculations. Okay. All right, now we know what that t-statistic is. It's minus 0.52, correct? And so what are the upper and lower values for this situation? And basically what we're going to do is in this sort of kind of scenario, your kind of more or less blended n is going to be your smallest value n, which in this case is 91 minus 1, and that's going to be your degrees of freedom. Is 91 minus 1, where I got the 91 from, once again, is right there. So 91 minus 1 is 90. Now I can use my handy dandy chart, and at 90 degrees of freedom, and we're at 95%, 1.987. And a plus 1.987. What is the p-value for the test statistic? Well, you can kind of see where this is going to start turning out. It's going to be a minus 0.52 as far as the actual t-value goes, and at 90, right, you're going to be off the chart. It's going to be well up into the well over p.20. So you can pretty much, like I said, figure where this is going. It's going to be your p-value is going to be something greater than 0.20. Your standard was p less than 0.05. So you're most likely going to accept the null. Sketch your normal distribution curve. This is 0. This is minus 1.97, 1.987, and this is 1.987. Here's your reject. Here's your do not reject. Everything in here or under the curve here. And so you're set up and you're ready to go. You kind of know where it's going, but let's verify that. You got a 0.52, and it's a negative 0.52. You're going to end up somewhere over here. You're definitely in the do not reject zone. If you had calculated a value that it was up in here from the original equation, which was x1 minus x2, and then you would most likely have gone a slightly different direction if that had been a positive number. But regardless, you are going to accept the null. There's not enough evidence. Do you reject or accept the alternate? You never got to the alternate, so you're going to reject the alternate. What is the answer to the research question? The research question that we were talking about was, who talks more, men or women? Well, in the research question, you knew that mu sub 1, this is kind of mathematical, is equal to mu sub 2. So in that situation, if mu sub 1 minus mu sub 2 is equal to 0, then everybody talks the same. And what you're finding here is that they do, these two numbers are pretty much the same, and so neither side wins the discussion, and by default, the husband loses the discussion. Now, I don't know. Anyway, so I don't know what the conclusion or recommendation here would be, but you just kind of work